Okay, students, in this video I would like to do analytic proof as inverse trig identities, the baseline, call them as set 1, this is set 1, there are 6, and you can see sine inverse, if it is negative, you can pull out the negative out, and the same thing is cot inverse, cosecant inverse, and cotangent, but except for cosine inverse and secant inverse, we have to write in pi minus. The question is why. So basically, if the question is simplify, what is sine inverse of minus root 3 by 2? So there's a negative here. So can we apply this formula directly? Yes, we can do. But before we even do that, let's see why. So I'm going to start with the first one. Why sine inverse of minus x is minus of sine inverse of x. So let me start here. So sine inverse of minus x, or in place of x, let me call it as, I'll just number. So let's call this is, we want to know what is this answer, right? We want to know why it is minus sine inverse of x. So because we do not know, I'll put it like maybe the angle theta. Because sine inverse, the domain of sine inverse of x is minus 1 till plus 1, and the range is minus pi by 2, pi by 2. So let's see, so the value has to be, whatever the angle has to be from minus 90 to plus 90. First step is this, by definition of sine inverse, we can write this as negative x is same as sine of theta, right? Then multiplied negative 1 both sides, so you multiply minus 1 both sides, and this will be negative negative will be positive x, this will be minus sine of theta. And then this is, because you're multiplying minus 1, so multiplying negative 1 both sides by negative 1 this side and negative 1 this side, you get this. But then we know from trigonometric identities that this can be written as, we have proved earlier, this minus sine theta is same as minus sine theta because of the formula. Then again we can use the definition. If x is sine theta, you use the inverse trigonometric function. It will sine inverse of x equals minus theta, and again multiply minus 1 both sides. So this would be minus sine inverse of x, and this would be just a theta. Replace your theta back here. So that's sine inverse of x equals inverse of minus x. And that proves. Now why it is easy, needed is, if you see this example here, we can directly write this as minus sine inverse of root 3 by 2. And you do know that sine of what angle is root 3 pi by 2. So we know sine of, so the answer for this is pi by 3, because sine of pi by 3 is sine 60, which is root 3 by 2, and you're done. So that's how we can easily do that. Otherwise, you need to think this as, what does this basically mean is, you have to think of the arc this way, and you're thinking of, see this part? So minus root 3 by 2, so this part, this is 1, 0, this is minus half, this one is minus root 3 by 2, and this one is minus 1. As I said, because the first one is always cosine and the sine, so it's sine 30, so we see the y coordinate is half here, so if this is 60, then it is root 3 by 2, and this one is 1. So instead of thinking too much here, that inverse of sine, inverse of minus 3, so you're thinking of this minus root 3 by 2, and checking this angle is that minus pi by 3, because it's clockwise. So a lot of thinking is needed to figure out that. If you think this way, you can get the answer. because the y coordinates are the sine values. So sine 90 is 1, sine 60 is root 3 by 2, sine 30 is half, sine 0 is 0, sine minus 30 will be minus half, minus 60 and so on. So instead of all that, we can just stop this and say, hey, that's this, and then you directly write the answer. Let's check cosine. The second one is cosine inverse of minus x is theta. Same thing by definition of trigonometric, inverse trigonometric function. This means x equals cosine of theta. Multiply minus 1 both sides. So multiplying this two negative makes it positive. This will be minus cosine theta. Now remember, I want to write this in terms of cosine of what? Okay. So by trigonometric identities again, this is same as, first of all, if I want to have a cosine, cosine is negative in the see this part, cosine is negative here. The first x coordinate is always cosine. So those are the two places. Now when you think of the reference angle, look at this. If you have this, whatever the theta, this should be, this is pi and before. So either the angle is just less than 180, you can have, or you can have more than also. But the cosine inverse, remember cosine inverse, the domain and the range is the same for inverse and even for cosine inverse. In cosine inverse, the domain is minus 1, but the range is the restricted domain from 0 to pi. That means it is from 0 to 180 degrees. So in other words, you can't have an angle more than 90. That's not possible. So the only angle possible should be smaller than this. So that's why we need to subtract from 180. So this can be written as 180 degrees minus theta. Okay? And then you use the definition of inverse. So this becomes cosine inverse of x. 180 is pi. And then I want to so what you can add theta. So let's add theta both sides. So theta plus cosine inverse of x is pi. And then you subtract cosine inverse of x. So let's subtract this. So both sides. So this will be theta is pi minus cosine inverse of x, and replace what is theta. This theta is this one, goes back here. So you get cosine inverse of minus x is pi minus cosine inverse. Done. So this could be used an example. The same thing even works for secant also. You can use the sine inverse, the same proof, whatever I showed for sine inverse, you can apply also to tan inverse, works the same way. Now imagine if this was the question before. So secant inverse is, there's a minus, you can just write this as pi minus secant inverse of 2 square root of 2, right? Then this is pi minus. Now, secant of what angle is 2 over root 2. Now remember, secant, if you forget, so cosine of pi by 4 is root 2 over 2. That is cosine of 45 degrees is root 2 over 2. So that means if I take secant of pi by 4, it means it is 2 over root 2, right? And you can write this pi by 4 is secant inverse of 2 over root 2. And right here, so secant inverse of 2 over root 2 is pi by 4. So are we done? No, we can still go. So we need to have a 4 here, so multiply 4, both up numerator and the denominator, you get 4 pi, and the answer is 3 pi by 4. So that's how we have to do. So hope this two proof helps. The goal was just to make sure I just show you one, this, but you can do the same thing with the rest of them. The trick is, the only for cosine inverse and secant inverse, the you have to write pi minus the rest of them. You just pull out the minus sign outside. I hope that helps. Try the other one, those formulas by yourself. Stay tuned. I'm gonna do next is we will try to see. I'm going to make another video, short video, is when there are combination of, let's see if you have sine or sine inverse of, let's see half, what is the answer? Or cosine of, let's say 3 pi by 4 or 3 pi by 2 pi by 3. And this is inverse. So we want to know how do we do those kind of problems. That's what I'm going to track. So usually the students, they just say, hey, they are inverse, and they say 2 pi by 3. So the question is it valid, is it right or not? So that part we'll see in the next class. Thanks for watching.